After losing their electric generators,
Okay, beacons off.
the pilots of Air Illinois Flight 710 shut down one system after another to conserve their battery power.
It was probably the most sickening feeling for both of them.
But efforts proved futile. All the passengers and crew are killed. NTSB investigators examined the plane's electrical components for clues.
There's no short circuit.
What about the batteries?
No signs of arcing.
The cockpit voice recording raises more questions.
Are you using these lights here?
I'll get that one down.
Well, they're doing the right thing. Turning things off to reduce the load. So, what happened?
You got a flashlight?
Yep.
Air Illinois Flight 710 departs from Capitol Airport in Springfield, Illinois.
Gear up.
32-year-old Captain Lester Smith has been with Air Illinois almost 5 years. He's one of its most experienced pilots.
Gears up.
First Officer Frank Tudor has been with the airline for 3 years. He's considered one of its top first officers.
1,000 feet.
The pilots are flying a Hawker Siddeley 748. The rugged turboprop is designed to land on shorter runways.
The Hawker Siddeley 748 was one of a number of aircraft built to replace the DC-3 as a commuter slash cargo slash military type aircraft, but primarily used as a commuter aircraft.
It's the ideal plane for a regional airline that connects big cities to small towns in Illinois.
Illinois 710, radar identified. Continue to 3,000 feet, cleared to Carbondale.
Illinois 710.
3,000 feet, cleared for Carbondale. Thank you and good night.
Heading 175.
Less than 2 minutes after takeoff,
It's the generator again.
a generator warning light comes on. The aircraft is equipped with two 9-kilowatt generators that supply power to the battery banks and electrical systems. One of the generators has failed.
Isolating it now.
The first officer disconnects the right generator to protect the rest of the aircraft's electrical system.
When something like this happens and you have a generator failure, one of the most important steps is to disconnect that generator from the system as quickly as possible.
Janine Urban is a former Air Illinois pilot who landed the plane in Springfield 3 hours earlier.
The generators are each rated to be able to carry the entire load. So if one generator goes down, you can continue to your destination. It is not an emergency.
Tonight's 40-minute flight is taking 7 passengers 146 miles from Springfield to Carbondale, Illinois.
Springfield, Illinois 710. We've experienced a slight electrical problem. We'll keep you advised.
Illinois 710, do you intend to return to Springfield?
Negative. Continuing to Carbondale. 3,000 feet.
The captain decides it's safe to continue the flight.
I understand you are continuing to Carbondale.
Roger.
There's dense cloud cover this evening.
The conditions at Carbondale were what is called IFR, Instrument Flight Rules. They would have been operating in the clouds, needed their instruments to be able to fly the airplane.
They were flying into deteriorating weather conditions. It's something that every airline pilot is trained to handle, but it doesn't give you much room for error.
4 minutes after takeoff, the first officer checks the status of the generators.
0 voltage and amps on the left side.
He discovers that the left generator is dead.
The right generator is putting out 27.5 volts.
The right generator now appears to be working, but the first officer is unable to reconnect it to the electrical system.
Can't get it to come online.
The right generator is as good as dead.
With both generators out, all the systems are feeding off the batteries instead of the generators. It's not a good situation.
The aircraft has 4 nickel-cadmium batteries. With no generators, the batteries are now powering lights, instruments, navigational equipment, and everything in the passenger cabin.
How are the bats there?
We're down to 22.5 volts.
So now that we're operating on only battery power, the primary problem is that the batteries are only designed to operate for about 30 minutes under the best case scenario.
Illinois 710 is now 32 minutes from its destination. If they don't reduce the drain on the batteries, it will be almost impossible to land without lights, instruments, or a radio.
Okay, beacons off.
Okay.
Nav lights are off. Are you using these lights here?
I'll get that one down.
The pilots quickly shut down non-essential systems.
The sooner they start shutting things down, the longer the battery is going to last.
How are the batteries?
Pretty good. They're at 21.5.
The efforts to conserve battery power seem to be paying off.
Should last to Carbondale.
Yeah.
Midway to their destination, the weather deteriorates.
The weather that Frank and Les encountered trying to get down to Carbondale was much stormier than Springfield. There were level 2 and 3 thunderstorms.
Want me to tune into Cabby real quick?
Sure. Not gonna use that much power.
45 miles from Carbondale, the crew tunes into a signal that will provide a precise bearing to the airport. Meanwhile, air traffic control transfers the flight to the approach frequency for southern Illinois.
Air Illinois Flight 710, contact Kansas City Center on frequency 125.3.
25.3, Roger.
Air Illinois 710.
They were getting close to the airport, and that approach control facility would have lined them up for an instrument approach.
After contacting approach control, the situation worsens.
I don't know if we have enough juice to get out of this.
The radios and transponder on Flight 710 have shut down. The pilots are now on their own.
Illinois 710, I've lost radar contact.
Flight 710 has disappeared from air traffic control's radar.
Illinois 710, Kansas City.
They had no capability at this point to get help. It was probably the most sickening feeling for both of them that you or I could imagine.
Watch my altitude. Going down to 2,400 feet.
Concerned their instruments are about to fail, the captain attempts to get below the clouds.
He was desperately hoping that he could see the airport beacon or some runway lights and land that airplane visually.
Just 8 minutes from landing,
You got a flashlight?
Yeah.
the batteries are almost depleted.
Here we go. You want to shine it up here?
Trying to illuminate the instruments with a flashlight in a dark cockpit that is very abnormal. And is he pointing it at an instrument that's functioning or one that's not?
We're losing everything down to 13 volts.
Watch my altitude, Frank.
it would have been a total panic situation and realizing that they were out of options.
Okay, 2400.
Rapidly losing electrical power and operating in total darkness, the pilots of Illinois Flight 710 desperately try to land their plane.
The conditions at Carbondale were such that 1 mile visibility in light rain and fog. His chances of seeing anything were minimal at best.
Do you have any instruments? Do you have a horizon?
They're in a dark cockpit. Instruments are failing. They can't see anything outside. They were now into a critical emergency.
Okay, you're banking left, 6 degrees.
Okay, correcting to the right.
A little more.
Illinois 710, Kansas City, do you read?
I would be very surprised if they knew that they were going to hit. I would be very surprised they saw the ground at all.
Air Illinois Flight 710 crashes 25 miles north of Carbondale Airport. The wreckage is scattered across farmland near the town of Pinckneyville. All 7 passengers and 3 crew members are dead. The National Transportation Safety Board, or NTSB, begins an investigation to determine what happened to Flight 710.
Let's see what we got here.
They begin by reviewing the debris pattern.
It's a half a mile long and roughly 200 feet wide.
Investigators get a sense of the vast impact area, which extends across 2 small wooded areas, a field and a pond.
They came in at a shallow angle.
The wreckage pattern gave us the idea that this was a fairly high-speed, low-angle impact to be able to spread the wreckage like this over a half a mile.
First point of impact is right here, with ground scars and debris heading north. Carbondale Airport is 25 miles to the south.
Investigators determined that at the time of the crash, Flight 710 was flying in the opposite direction to its destination.
With the aircraft traveling the way it was at that speed and in a wrong direction, it made us wonder, was the aircraft actually under control?
So first ground scar here, followed by a few more, and then 200 feet in front of that, the right wing tip.
Near the first impact marks, investigators discover fragments of a green navigation light from the plane's right wingtip.
It was banked to the right when it hit the ground.
We had the right wingtip. We knew that was the first thing that hit the ground, and we could measure approximately 30-degree right bank.
Did the crew report any issues to air traffic control?
Yeah, they did.
Springfield, Illinois 710. We have experienced a slight electrical problem. We'll keep you advised.
Investigators learned that 90 seconds after taking off from Springfield, the crew reported an electrical problem.
Anything else?
That's it. Just the electrical problem.
We'll need to take a good look at all the electrical components.
The pilot reported a slight electrical problem, and it was up to us to figure out what his problem was and why they crashed.
Is this everything?
Investigators examine electrical components for evidence of malfunctions.
Wires are clean. There's no short circuit.
This inverter's in bad shape.
Hard to tell if they were working or not.
What about the batteries?
4 NiCad batteries are powered by 2 generators. Each battery contains 18 individual battery cells.
No signs of arcing or short circuit as a result of impact.
We were able to recover a total of 10 cells from the batteries, and they were all in decent shape.
Well, let's see if they can hold a charge.
Under normal conditions, the batteries should be fully charged.
Wow. They're dead.
The batteries were able to hold a charge, but for some reason they were run down.
Did the generators malfunction and fail to charge the batteries?
The left generator?
Aircraft engines power a generator shaft to rotate a metal core wrapped in copper coil. This is known as an armature. The armature spins rapidly between the poles of a magnet to generate electricity.
Banding wires come off.
Banding wire is used to hold the armature together as it spins inside the assembly. If the banding wire comes loose, the armature could jam.
Soldering is melted. The motor must have overheated.
Investigators discover evidence that the left generator failed.
This happened before the crash.
We know that there was no fire on the aircraft, so we believe that the solder melted due to internal heating, but we don't know why.
They then inspect the right generator.
The banding wire's intact on this one.
Looks fine.
We did a resistance test, checked the brushes, and we looked at all the mechanical workings of the generator. We were not able to find any reason why the right generator would not charge the batteries.
How did they crash with 4 working batteries and 1 working generator?
From examination of the wreckage, we were not able to find any reason for the accident. We were hoping that the voice recorder would give us clues as to what really happened.
The recording starts around 4 minutes after takeoff.
Investigators turn to Flight 710's cockpit voice recorder to determine how an aircraft with 1 functioning generator crashed short of its destination.
Zero voltage and amps on the left side. Just like we suspected.
The CVR recording confirms that the left generator failed shortly after takeoff.
The right generator's putting out 27.5 volts.
But I can't get it to come online.
Investigators can't understand why the right generator was disconnected from the electrical system if it was operational. Then they hear an astonishing statement from the first officer to the captain.
When we lost the left one, I reached up and shut off the right generator because I assumed the problem was the right side.
Isolating it now.
There are 2 shut-off switches for the generators. 1 for the left generator and 1 for the right. The first officer disconnects the right one to protect the rest of the aircraft's electrical system. But he soon realizes that it's the left one that has the issue, not the right.
Why doesn't he just reconnect it?
He tries, but it doesn't work.
The right generator was not charging the batteries, so that we know all they had to power the aircraft was the charge remaining on the battery shortly after takeoff.
Maybe there was a problem with the switching unit.
If the generator switching unit is not working, then the generator will not come back online, so we were quite interested in learning what we could about this component.
It's in pretty rough shape.
Looking for signs of a malfunction, investigators examine the right generator control switch.
can't tell 100%. It's possible it failed before the crash.
The switching unit was heavily damaged from the crash. We were not able to determine if that's even why the generator would not come online.
Even if the switch was broken, it doesn't explain the pilot's actions.
The first officer says, I assumed the problem was with the right side. Why would he assume something like that?
It made us wonder if there was a problem with that generator in the past.
Take a look at these maintenance reports.
The team reviews the maintenance records for the Hawker Siddeley's generators.
Check it out. No less than 8 separate pilot complaints and repairs on the right generator.
There were voltage fluctuations, recurring problems at the regulator,
causing the right generator to shut down.
2 weeks before the crash, there were issues with the right generator almost every day.
They were doing maintenance, they were troubleshooting it, they were changing parts, and they couldn't fix it.
Air Illinois had 1 Hawker Siddeley and 3 flight crews flying that plane.
I'm sure that they all knew that the right generator had had problems in the past, and they probably all experienced it at one time or another.
The first officer had been on some of those flights where the right generator had actually disconnected. Thank goodness I was not. The most I ever saw it do was flicker a time or two.
That would explain why the first officer disconnected the right generator instead of the left one.
Investigators suspect that on the night of the crash,
It's the generator again.
the first officer made the immediate assumption that the right generator had malfunctioned.
The reaction that the first officer had about taking the right generator offline probably falls into a phenomenon that's called expectation bias. He has experienced this in the past and assumed that that was going to be the problem without really looking at the indications he had available to him.
Still doesn't explain the crash.
Even though both generators were offline, investigators know the aircraft's batteries were in working order.
How are the batteries?
Pretty good. They're at 21.5. Should last to Carbondale.
Yeah.
It was really important to know, did the batteries have enough endurance to get to the airport?
Let's see how they manage their battery power.
Investigators return to the cockpit voice recorder to determine why Flight 710 ran out of battery power before reaching Carbondale.
How are the bats there?
We're down to 22.5 volts.
Okay, beacons off.
Okay.
Nav lights are off.
Just minutes after discovering both generators are down, the pilots turn off non-essential systems to save their batteries.
Well, they were doing the right thing, turning things off to reduce the load.
But is it enough? According to the manufacturer, they needed to reduce their load to 70 amps.
Amps measure the strength of an electrical current. The more amps drawn on a battery, the faster the battery will discharge.
If the crew would have reduced the load to 70 amps, that would have given them a minimum of 30 minutes of endurance. That might have been enough time to get them to the Carbondale airport.
Let's see if they got their load down to 70 amps.
Well, we know they turned off the beacons, navigation lights.
Investigators make an inventory of the instruments the crew turned off and what they left on in order to calculate the load on the batteries.
What else?
Are you using these lights here?
I'll get that one down.
We were not able to determine what was powered up or on or off based on the flight recorder.
Should last to Carbondale.
So we had to rely on the conversations between the two pilots, what to leave on and what to turn off.
Want me to tune into Cabby real quick?
Sure. Not gonna use that much power.
The DME instruments, weather radar, the main cabin lights. one of the main radios, a cooling fan, and the transponder.
The weather radar and the radios draw a lot of power, and so shedding those, if you can, is a prudent thing to do.
Looks like they kept the rest of the flight instruments on, and that's it.
They used 110 amps.
Investigators discover the crew did not properly reduce the draw on their batteries.
No wonder they didn't make it to Carbondale.
This importance with load shedding and getting down to 70 amps seems to be lost on the crew, as there seems to be no discussion whatsoever about amperage to determine if their changes in the electrical system were actually making a difference in the longevity of the batteries.
So why did the pilots believe they had enough power to reach their destination? The team checks to see how the pilots monitored the state of their batteries.
It says here, fully charged, the batteries are 24 volts.
Let's see how they did.
How are the bats there?
We're down to 22.5 volts.
8 minutes into the flight, they used up 1.5 volts. 7 minutes later...
How are the batteries?
Pretty good. They're at 21.5.
The battery charge drops another volt to 21.5.
The first officer says the battery should last to Carbondale. They're halfway through the flight. He's feeling good.
And then 9 minutes later, he checks again. It's 20 volts.
So they think they're doing all right.
And then minutes later, the radios go dead.
We're losing everything down to 13 volts.
They're talking about having 20 volts, and then they all of a sudden they have 13 volts.
So they're monitoring the volts, but it's as if the sudden drop caught them by surprise.
The reason this is significant is because NiCad batteries will maintain their voltage almost right until the end that the batteries are dead. Much different than lead acid type batteries, which is where you see a gradual decline in voltage.
That characteristic of NiCad batteries may explain why there was such a sudden drop in the battery voltage.
I don't know if we have enough juice to get out of this.
If they would have known the characteristic of a NiCad battery, it might have sent them a message saying, we better get on this right away and get this load reduced.
Investigators find another reason why the crew may have missed how fast their batteries were discharging.
They never mentioned their amps. Looks like the only thing they monitored were the volts.
Volts measure the potential output of a battery, not how long it will last. Amps tell you how much electricity is being drawn.
It was very surprising that they weren't monitoring the amperage, because that was going to tell them how much longer they had on the batteries.
Did the crew have the proper training to monitor the endurance of the batteries? Investigators interview other Air Illinois pilots
So what'd you find out?
to determine their ability to monitor and calculate battery endurance.
Well, we know that they were all trained on battery management for a dual generator problem. But when I asked them how long they thought the batteries would have lasted on the flight, some calculated 30 minutes, others less than an hour.
5 pilots gave us 5 different answers, and they were not all correct.
It became obvious to us there was definitely a training issue involved here.
Are you using these lights here? I'll get that one down.
The lack of training explains why the pilots thought they had enough power to reach Carbondale. But that doesn't solve a bigger mystery.
This is their flight path.
Why didn't the pilots land the plane at another airport before completely running out of battery power?
1, 2, 3, 4, 5 different airports.
They were only 5 minutes away from Springfield, yet they elected to go 40 minutes to Carbondale. And there were several airports in between that they missed.
They could have landed any time along the way.
Their decision not to land calls the pilot's judgment into question.
It's time to look into their backgrounds.
Here's the captain's file.
Investigators dig into the backgrounds of Flight 710's pilots for clues that explain their unusual reaction to an electrical failure.
The captain was perfectly qualified.
Same with the FO.
Gear up.
The two pilots were among the most experienced flight crew on the roster,
Gear is up.
with a combined 5,000 flying hours between them on the Hawker Siddeley.
Here's something. The captain lived in Carbondale.
Maybe you want to get home?
In aviation, what we describe as get-home-itis is when we try to make it to the destination because of our strong desire to do so. And it plays a significant role in our decision-making.
Investigators talk to other pilots at the company, including First Officer Janine Urban.
How well did you know the pilots?
I flew with the captain, and I was good friends with the first officer.
I thought very highly of the first officer, Frank. I knew the flight attendant, Barbie, and liked her a lot. It was a very emotional thing to hear that both of them had been killed.
What sort of pilot was the captain?
I'd say average.
In the aviation community, when someone is characterized as an average pilot, that usually means he's not too good.
Why's that?
The captain really prided himself on getting there on time.
It was not uncommon for him to take risks.
Looks like we've got some weather. Shall I call for deviation?
Doesn't look too bad. We'll be fine.
According to Air Illinois pilots, the captain would often fly too close or through dangerous storms to save flight time.
If I made any comments or suggestions about a safety issue like the thunderstorms or anything else, he would do something spiteful just to prove that he was the captain.
In order to keep schedule, he'd also speed up, which would set off the overspeed alarm.
Pull the circuit breaker, would you?
What? Really?
Pilots said he would order them to disable the overspeed warning so that they could fly faster.
It was always about getting there faster.
The captain's behavior is troublesome.
We wanted to know if the company, the airline, was putting undue pressure on the pilots to make the schedule.
This pressure to get there on time, was it from management?
No, it was all the captain.
The interviews with the other pilots indicated that there was no undue pressure to skirt the rules. In the case of the captain, that pressure was self-imposed.
Investigators conclude that Captain Smith often stretched the rules.
What about the first officer?
Frank was the best. And he knew the plane and its systems really well.
So why didn't the first officer speak up when Captain Smith made the decision to carry on?
Illinois 710, do you intend to return to Springfield?
Negative. Continuing to Carbondale, 3,000 feet.
And at no time did we hear the first officer challenge the captain's decision to go on to Carbondale. We found this very perplexing.
I asked how he could fly with the captain because he took so many chances.
And he said, oh, I just try to keep an eye on the situation and not let him get us into anything that I can't get us out of.
We're losing everything down to 13 volts.
Watch my altitude, Frank.
Boy, that didn't work out very well at all.
the captain should have made the decision to return to the Springfield airport. And if so, none of this would have happened.
Thank you.
Investigators conclude that the risk-taking captain and an unassertive first officer was a dangerous combination.
Let's pick it up from where they realize they don't have enough power to make it to Carbondale.
The team returns to the cockpit voice recording to see if they can uncover why the plane ended up so far off course.
Watch my altitude. Going down to 2,400 feet.
Okay. Stop the tape.
Why would the captain decide to drop down to 2,400 feet?
The cloud ceiling near Carbondale was almost 2,000 feet, so maybe he was popping in and out of the clouds to see something on the ground. Play on.
You got a flashlight?
Yeah.
Here we go. You want to shine it up here?
Just as the captain tries to see the ground, the cockpit lights go out and plunge them into total darkness.
We're losing everything down to 13 volts.
Watch my altitude, Frank.
Okay, 2,400.
They make it to 2,400 feet. The captain plans to level off, spot the runway, and continue his descent. But that's not what happens.
Okay, you're banking left. 6 degrees.
Okay, correcting to the right.
Just minutes later, they ended up crashing in completely the opposite direction.
A little more.
So the question is, what happened?
How do you go from leveling off at 2,400 feet to then hitting the ground in the opposite direction?
Investigators examine the final moments of Flight 710 to determine what ultimately brought the plane down.
How does the recording end?
Do you have any instruments?
The recording eerily slows down.
Do you have a horizon?
And then, silence.
Their batteries just died.
The captain is asking for a horizon reading on the Attitude Directional Indicator, or ADI. The ADI uses an electrically powered gyroscope to indicate the aircraft's pitch and roll relative to the Earth's horizon.
It's nighttime, no discernible horizon, low visibility. Your ADI is everything that you need to be able to keep the airplane wings level.
They've lost the lights on their instruments. Some of them are starting to fail. He asked the first officer to shine a light on their ADI.
Okay, you're banking left. 6 degrees.
Okay, correcting to the right.
Investigators can only surmise what happened next.
Even if all the instruments had failed, the ADI would still look like it's working.
The ADI gyroscope spins at about 15,000 RPM. Even after the power shuts down, it will continue rotating for several minutes.
So it looks like it's working, but it really is not.
As the ADI winds down, it slowly tilts to one side.
Imagine that ADI starts slowly falling to the left.
Hit correct by rolling to the right.
Okay, you're banking left. 6 degrees.
Okay, correcting to the right.
A little more.
It may have appeared to them that the ADI was working correctly, but they're really banking to the right and losing altitude.
They probably followed that failing ADI right into the ground.
They couldn't see where they were, they couldn't see any lights, and it would be over in an instant.
In their final report, investigators conclude that the fatal accident was a consequence of the captain's decision to continue the flight towards Carbondale instead of returning to the nearby departure airport after the loss of power.
The cause of this accident was not a catastrophic failure that suddenly caused the airplane to crash. It was the decision by the captain to continue flight on battery power after they lost the generators.
Also adding to the problem was a lack of crew resource management, or CRM.
Now part of crew resource management training is that crews are trained to act as a team, and first officers are taught and encouraged to question the captain's decision-making and actions if they do not agree.
Speak up. Don't worry about if it upsets somebody's ego. It's not worth dying over.
Investigators cite inadequate crew training to assess battery endurance as another contributing factor.
It should have been discussed in their training. It should have been in their training materials and in the flight manual.
As a result of this accident, the NTSB also recommends independently powered ADIs on all transport airplanes.
So that if all power was lost, they still had the ability to keep the airplane straight and level for at least 30 minutes.
This recommendation was implemented in 1997. Flight 710 brought national attention and increased scrutiny of small commuter airlines. 6 months after the accident, Air Illinois filed for bankruptcy and ceased operations.
It's something where we learn by our mistakes. The first priority is the safety of the passengers is got to be the most important factor.